Hey everyone, what's going on? It's Kevin here. Today we'll be looking at the 2002 AIME 2, number 8. And here we want to find the least positive integer k for which the equation the floor of 2002 over n is equal to k has no integer solutions for n. Okay. So we want to focus on the part that it says no integer solutions for n. This is important because it kind of just assumes that there won't be integer solutions for n for some values of k. So with that in mind, let's test out some initial variables. So since we want to find the least positive integer k, let's start from k equals 1. So what does k equals 1 give us? So k equals 1, well, maybe you've already figured this out, but n equals 2002 just works. And in fact, n equals 2002 isn't the only thing that works in this case. And actually, pretty much every single n is less than 2002 gives the floor to be k. However, when we get below a certain threshold, then we'll cross into the next territory. So, for example, k equals 2 gives us n equals 1001 as like a flat equality. Thus, basically, k equals 1 is achieved whenever n is between 1001 and 2002. And of course, that inequality is going to be strict because 1001 will give k equals 2 rather than k equals 1. And in general, k is achieved whenever it's 2000 n plus 1 is less than n is less than or equal to, and these bounds might not be exactly right, but it's good enough for our scenarios where we can just approximate a range for the k that we're looking for and then just bash out the remaining values. So in general, we have an integer k whenever we have that 2002 over n plus 1, or n is between 2002 over n plus 1 and 2002 over n. Oh wait, that's k, that should be k plus 1, that's my bad. So what causes this to have no integer solutions? How can we have no integer solutions? Let's look at an example. Suppose, well, I'm assuming because we're finding the least positive integer k, that if we take a large enough k that we won't find any integer solutions for n. So let's take k equals 500, for example. K equals 500 as an example. So what does k equals 500 give us? This gives us, I think it's 2002 over 501, which is 1 less than n less than or equal to 2002 over 500. And as you can see, both of them are approximately 4. Now, we don't know if, well, we should check if 4 is actually in that range or not. So because 4 times 501 is 2004, then it certainly is greater than the lower bound. Oh, so it is in the range. That's not exactly what I wanted, but so 4 is indeed in the range. So it doesn't really demonstrate no integer solutions. I just picked that randomly, actually. And of course we could try to find a better example, but I think you get the point. Basically, if the bounds are too close to each other, then it's very unlikely for them to have any integer solutions for n, because basically the gap, like an integer has a squeeze between the gap of the two bounds, so the lower the bound is, the harder it is for n. So how can we make sure that an integer is not contained within this bound? Well, one way to start is seeing if basically the difference between the two bounds is greater than or less than 1. So why is this important? Why do we care about the bound will be 2002 over k minus 2 over k plus 1, mean greater or less than 1. And the reason for this is because suppose this difference is greater than 1. Because integers are separated from each other by units of 1, or at least adjacent integers are. So adjacent. Thus a difference larger than 1 would ensure that basically it's kind of like a generalized pigeonhole principle. Basically, if you have a gap of more than 1, then obviously, since integers are uniformly spaced with distance 1 from each other, then there has to be an integer between them. An integer is between the bounds, which is a contradiction because that means we get an n. Thus, so our conclusion is that in order to have no integer solutions for n, we must have 2002 over k minus 2002 over k plus 1 be less than 1. And it might, I guess it could be equal because like the bounds could be wrong, right? It's like, let's just say less than or equal to. It's not like it really adds much. But of course, the converse is not true. That is, if you have this bound 2002 over k minus 2002 over k plus 1 being less than 1, then that does not imply that there is no integer solutions, as we saw with the k equals 500 example. So that actually turned out to work out. So when does this happen? Now we can simplify a bit. So this becomes k plus 1 minus k is 1, so it's 2002 over k plus 1. What am I doing? Should be that here. is less than or equal to 1. Let's make it bigger. And what? Okay, weird. And then let's make it k plus 1 is greater than or equal to 2002. Of course, because k cannot be 0, k cannot be negative, and thus so you're multiplying positive numbers, so you don't need to flip the inequality. And this gives us that k is at least going to be at least, and this is when knowing your squares will be pretty important. So I know that 44 squared is 1976. So that plus 44 will be 2020, right? No, that's wrong. Of course that's wrong. Oh wait, it's, what am I saying? 19 squared, or 49 squared is, or 44 squared is 1936. So that would be 1980. So 44 times 45 is 1980. So that doesn't work. So k has to be at least 45. And now, I guess we can just try the first few values and see if we have one. I mean, since the gap is like less than or equal to 1, there has to be like 1 within the first few that we hit it, right? So let's quickly check. So let's check 45. So that is 2002 over 45 and 2002 over 46. The gaps between these. Okay, what is 2002 over 45 though? Is equal to the improper fraction 44 plus, that was 1980, right? So 22 over 45. Okay. And so we want to see if this includes 45 then. And is 45 less than 2002 over 46? 45 squared is 2025, so yes, it is. So that doesn't work. Let's try again. 2002 over 46 is rounds down to 45, I believe, because 46 squared is going to be like 22136 or something. So yeah. Wait, yeah, I think. Wait, 45 is less than, yeah, wait, I was confusing myself for a second. So the floor of 2002 over 46 will be, sorry about that, less than 45, right? Yeah, is less than 45. So we want to see if 45 is included. And in fact, let's just see, because it seems like to be floating around the 45 range. Let's just see when this ends. So 2002 over 45, we already calculated that, is equal to 44. Let's I don't know about that. Yeah, so 45 doesn't look like it works. It's never, or the bound 45 will never occur, or will always occur between two successive ones until a certain point when we cross the 46 threshold, I guess. So if you don't know what I'm talking about, basically, the first few things after k is 45, they all kind of like center around the 45 as an integer, and all of them include 45 because they don't surpass, or at least 2002 over k doesn't exceed 45, and 2002 over k plus 1 will always exceed 45. So we want to figure out when this thing surpasses 45. So this happens when k is less than, what am I doing? It should be at least 46, right? Wait, am I confusing myself even more? Let's just do the next few. I really think it will be in the next few. So yeah, I don't see a better method than just to batch these out, considering that each gap is like less than 1 and it keeps on decreasing. It shouldn't be long before we hit the answer anyways. So I think 46 didn't work, right? Is what we did already. So 47 and 48. Yeah, I don't really like this. Let's just 2002 over 47. I'm kind of lazy to do this. Okay, it's greater than 42. Oh, it's because stuff was decreasing, right? Oh, right. Okay, that makes much more sense. Okay, if it's greater than 42, then it has a sandwich 43, and 43 times 48 is I don't know, 1920 plus I don't know, plus 144, right? 2064, so it's greater. So I don't think that works either. So I think, like, okay, I obviously did this in a really bad manner. I think what should have been done, like on an actual contest, what I would do is, starting from 45, I would compute the floors of each of them and see the difference, and then it all becomes clear. In fact, let's just do that right now. Let's delete the last few lines. So let's just assume that when I'm talking about fractions, I'm talking about floors. So the floor of this will be, I think we computed this to be 44. 44. You know what? Let's just do greater than or equal to like symbolize the floor, I guess. 46 will be what? Okay, let's just 46 will be 45. 46, 44. I am confusing myself again. It's gonna be decreasing, right? I don't like this problem. What's 46 times 43? Let's just work that out. That is 90, 920, 1840 plus 8131987. So 1978. So that works. 47. You know what? These calculations I can always do. I'm kind of too lazy to actually like bash them all out. So just pull up a calculator. Okay, so this is 42. This is 41. And we're just watching for like a gap. And this is 40. And this is also 40. Okay, that's interesting. So I think that is our answer there. So it seems like K is 49 works, I think, because the difference, or at least the floors are both 40, so I think that should work. So let's test out K equals 49. Has no integer solutions for n. So for 49, I think it lies around 40, right? So let's test out so let's test out the stuff. 2002 over 40 is around 50 point something, 50 point plus 2 over 40, right? While 2002 over 41 approximately, let's calculate that, 41 is going to be 48.8. So that is, so yeah, it does skip over 49, so 49 is our answer. Okay, that took a lot longer than I thought it would.